Hi friends, today I'm going to be taking the topic transportation problem from resource management techniques or operation research. So what is the transportation problem? It is a special case of LPP. So when you are transporting goods or commodities from a particular source to a destination, the task that we have in this problem is to find the minimum transportation cost, okay, while satisfying the supply and demand. So you'll have to find out a ideal shipping schedule probably, which can be adapted so as to reduce the cost while satisfying the supply and demand. Okay, so let's just see a problem on this. So here you go. There is the source and there's the destination, and here is the demand and here is the supply. Okay, and the values that are present within the table are CIJ, which is the unit transportation cost that is taken to ship a good or a commodity from a particular source I to a destination J. Okay, so let's just proceed with the problem. The first step that has to be followed while solving this problem is to find the summation of the supply and to find the summation of the demand. So if the summation of the supply is equal to the summation of the demand, that means that the problem is balanced. Okay, now let's just go to the next step. So in this table you will have to find out the minimum value. So in the table, what is the minimum value? 1, right? Okay, 1. So you'll select this particular cell. Once you've selected the cell, check its corresponding row and column. Okay, you'll have to do this. Okay, amongst these two values, that is 3 and 8, find out which is the smallest. Amongst the supply and the demand, you'll have to find out which is the minimum. So you can obviously see that 3 is smaller than that of 8. So we'll populate this cell with 3, right? Okay. Yeah, so we'll populate this cell with 3. Done. Now when you do that, you will have to subtract that 3 from this demand, because we've taken it from this column. So just subtract it. Since it has become 0, cut this particular column. Okay, and also you have to subtract this 3 from the supply as well. So it will become 5, right? Okay. Now the next smallest element you have to check in the table. So we still have another 1. So we'll go to this one, and now you'll have to check which is the smallest value. So amongst 6 and 5, so we'll have to see this corresponding row and the corresponding column. You'll find out that 5 is the smallest, so populate it with 5, delete this and make it as 0 and make it as 1. Okay, right. Okay, so I'm populating it with 5, and this row has become 0, so I'm going to cancel this row, right? Fine. And I've also subtracted it from here, so it's become 1. Now the next smallest element. Okay, this row has been cancelled and this column has been cancelled, so the next smallest element is 3. Okay, so you'll have to check out the rows and columns which have not been cancelled yet. So this 3 has not been cancelled yet, so we'll have to populate 3. So from 4, amongst 4 and 5, which is the smallest value? 4, right? So I'll write down 4 over here, I'll make 0, I'll cut this whole row, I'll make this as 1. Done. Okay, now we'll have to see which is the next smallest element. So when you see, again you have another 4 over here. So in this 4 you'll have to check, corresponding row and column. When you check, you'll find out that 4 is the smaller, that is the demand is smaller than that of the supply. So we'll take 4 over here, we'll cut this 0, we'll take it, we'll subtract it from here as well, cut this column off, right? Okay, so now see what is the next smallest value, which is 8, right? So amongst 1 and 5, which is the smallest value in the demand, and so you're checking the corresponding row and column of from 8. So if you see amongst 1 and 5, 1 is the minimum value, so you'll populate it with 1, you'll make it 0, you'll make it as 4, and then just cancel this whole thing. Okay, now amongst 9 and 12, 9 is the smallest, so you'll have to take that. You'll check the corresponding row and column from 9. So amongst 3 and 4, 3 is the smallest, so just write it down here. 3, write down 3 here, put 0 and write down 1 here, and then cancel this whole column. Now we'll have only one more element left, which is 12. So we have both corresponding row and column both represent 1, so we'll have to put this 1 here, and yes, we'll cancel it, right? So 0, 0, and cancelling out this particular row and the column. So, and one last step, we have one last step left for this in this whole procedure. So that is to check whether it is a non-degenerate solution or not. So for that we'll have to use a formula m plus n minus 1. So we'll see that m corresponds to the number of rows and n corresponds to the columns, right? So the number of rows is 3, columns is 5, minus 1 is equal to 7. So if this value is equal to the non-negative, is equal to the number of non-negative allocated cells, then it is said to be non-degenerate. Okay, so now let's see how many cells have been allocated. So I'm just going to mark the cells that have been allocated. I'll just underline it for our understanding. So yeah, 1, 2, 3, 4, 5, 6 and 7. So the number of non-negative allocated cells is equal to the m plus n minus 1. Thus it is a non-degenerate solution, non-degenerate basic feasible solution, right? Now you'll have to find out the cost as well. So let's just do that, right? Okay. Which is, how will you do that? So you'll have to multiply these two values, right? Okay. So that is 3 into 4. Okay. And these two values you're multiplying, plus 1 into 3, plus 1 into 5, plus 9 into 3, plus 4 into 4, plus 8 into 1, plus 12 into 1. Okay. This is what you're going to do here. Okay. So you'll get the value as 83. So which is rupees 83. Okay. Rupees 83. Yeah. So this is what the problem is. So this is the least cost method that we followed. So in the next video I would like to upload northwest corner rule. So thank you guys so much for watching. If you like this video, give it a big thumbs up and don't forget to subscribe.